Okay, so we can start. We would like to invite you to the presentation how OCP helps ING Bank reduce TCO and increase the user experience. So my name is Jaroslaw Sobel. I am IT architect in ING Bank in Poland. I'm responsible for private cloud, and privately I'm very interested in public clouds and software development. If you can get some information, you can reach me via LinkedIn or Twitter.
Hi, my name is Mikołaj Kujawa. I am IT expert at ING Bank in Poland. My main focus is on virtualization in general with Citrix products and performance analysis. Thank you.
So we would like to tell you something about ING Bank in Poland, and then we'll show you two steps that we've done with OCP in our organization. So ING Bank Śląski. I guess most of you, especially from Netherlands, knows about ING Group. It's the financial institutions with 51 employees all over the world in more than 40 countries. And Bank Śląski was a part of National Bank in Poland. It was developed in 1989. And from 1996, as you can hear right here on the screen, it was acquired by ING Group, and right now it is the part of it. That's why it's called ING Bank. We are one of the top 3 banks in Poland with almost 4.5 million retail customers. And we are very innovative. On the right-hand side, you can see our bank application. It's called My ING. And it was downloaded by almost 2 million customers. And just to prove it, this is the list of IT awards that we already gained. And the history that we've done with the OCP. We started our journey at the beginning of 2016 because we know that developing changed. That's why we started discussing about the microarchitectures, containerizations, and so on and so on. That's why we have to also think about the new hardware approach. So we start discussing with some vendors how we can achieve it on the hardware level. Thanks to the Quanta, in the Q3 2016, we just get some stuff to our data center. We'll show you later what it was. And we've done some tests and POCs. Unfortunately, due to business priorities, at the beginning of 2017, we had to stop this whole project. But fortunately, at the end of this year, at the end of 2017, we could start doing some OCP stuff in our bank, but for other purposes. It was for Citrix environment that Mikołaj will discuss it later. And right now, we are almost in the end of 2018. We are in production with our stuff, and we are finishing user migrations. So the first stage. Our internal code name, it was a Google-like, because of the approach to applications, and like because of the Facebook and the hardware. The main goal was to get some servers that will be small and especially cheap. Mostly with one CPU, with the much more better performance. That's why we started looking for Open Compute project. We know that there was some hardware that was already developed by Facebook with help with Quanta. We didn't want to get with the virtualization, so we want to go with bare metal, only with Docker containers, with microservices. And one more very important thing, we wanted to have standardized components. As my previous speaker said, for example, from Booking, they've got some issues with replacing the hardware. So we are also thinking about this. It should be standard that we can just replace all the gears. And in March 2015, Facebook just presented their new servers, one-socket servers. It was called Yosemite, the whole platform, with those small 4 monolake servers. And fortunately, thanks to QCT, Quanta Cloud Technology, we get those servers in the middle of 2016. So we get those chassis to our data centers just to do some tests. This is the high-density servers. In this one sledge, you've got 4 nodes, 4 one-socket nodes, with 128 gigs of RAM, with 1 small SSD disk, and one 8-core processor. This is some pictures from, as it say, unboxing. So you can see we didn't have any issue just to putting it to the data centers, as my previous colleague said. But as you can see, we had to do some replacing with the plugs. So we didn't have, it wasn't so easy, but finally we just install it. These are the nodes. And here you can see the test rack. It was the half-size rack with the JBOD, with Leopard servers, with the Power Shelf, and the Yosemite platform. So what we want to achieve, we want to do some, we want to redesign our application that will be working, and this is very basic approach. This is one Yosemite node, one monolake, one server node. We've got Linux OS, we've got Docker layer, and then we are starting some applications as a Docker containers, applications with Redis cache, with Cassandra database. This one node is in one data center. The second one is in the second data center, and the third node we've got in third data center. We wanted to achieve to replicate the data across all the data centers, and on the top of it we've got the load balancer with some additional features. So if user just connect to the application, if one whole data center goes down, the whole applications just remain active, and user didn't see if there was any issues with the application. So as I said, what we wanted to achieve, microservices, 3 data centers, load balancing and service discovery. It was the hardware and software problems. And unfortunately, when we get all those gears to our data center, it haven't been very good documented. So there was some documentation from OCP, but we didn't get any information about OpenBMC, about IPMI, and so on and so on. So frankly speaking, we had to do lots of stuff in management layer by ourselves. If you remember the movie Space Odyssey 2001, there was two heroes. The first one, the astronaut, it was the Dave, and the second one is the space computer, the main computer of the spaceship. It called HAL. They just talked to each other during the whole journey. So we just create 2 tools. The first one, it was the HAL, hardware abstraction layer. It was responsible for hardware monitoring. It just communicate with all the servers and verify the status, the power, the sensors, and also do the OS provisioning. The second one, Dave, it was the container manager. It just utilized the Docker API and communicate, provision the containers, and treat all the application layer to be working. Someone can ask why we didn't use the Kubernetes or Docker Swarm, because it haven't been major enough, and it didn't fit our requirements. That's why we just developed it ourselves. We also had some web GUI just for operators and IT guys from data center. So this is just a very basic description. This is one tray. In each tray we've got 4 one-socket server. And on the top of it, we install Linux, Docker, and then we've got those application containers. Also the console, this is the service discovery, just to communicate and verify what application is running correctly. And at the bottom, we've got this management layer. So we've got our Dave, our HAL, MongoDB as a database, just to verify and store some informations. And of course, some services just to serve, just to start and utilize all the servers. This is some basic diagram how it communicates. Of course, when you've got some new hardware, you still have to maintain it with the monitoring, with the CMDB, so the configuration management database. So all we have to do, we have to implement it in the hull just to push some data to our internal databases. So it wasn't the separate island. And what we have achieved. As a financial institution, security is our main goal. So we start thinking about the whole architecture just to deliver the security by design. So first of all the servers were stateless. So when you just turn off the power and turn on again, all the system were installed on the system, on the disk. So if you've got any issues, if there were any malware, something like this, it was just rebooted and the whole servers were purely clean. There was no SSH access, so there was no administrative login. All the logs should be pushed out, for example, to Kafka or other PubSub storage. And as I said, looking for the first point, if there were any problems, you should check the logs and then restart the server. So this was the main goal. We also have thinking about live Linux. So as it, for example, the Ubuntu just starts and then you reboot it and you've got the fresh one. This was one of the steps that we also would like to achieve. And the network segmentation, we use the software-defined network just to separate the application domains, just to spread all the traffic across all the servers. All those applications will fault tolerant. As I showed you on the previous slides, if one application, one node just goes down, user didn't see any issues from the application point of view. Netflix, a couple of years ago, Netflix developed something called Chaos Monkey. It's some approach just to test the whole environment. So they just turns down one data center just to verify if its whole environment is working. Looking for those principles, we were Chaos Monkey ready. So we could do the same similar tests just to verify if our application is running. And of course, very buzzwords today, AI and machine learning. We wanted also implement those AI and machine learning algorithms to our software just to verify and just to keep them learning and improving whole the process. Okay, so this was the first step, and as I said, due to business priorities, we had to stop it. So.
Okay, thank you. So, as Jarek said, this project was stopped. Nevertheless, we found the place for the OCP in our Citrix environment. How many of you have contact with the Citrix products? Raise your hand. Okay, some of you. So basically, we use Citrix XenApp and XenDesktop solution to deliver remotely applications and virtual desktop to our users. In numbers, we have 3,500 users in branch offices connecting to our terminal servers, which are running in data center. Now, let's go back to the year 2016. Where were we? We planned a migration of our operating system, our terminal servers, from the Windows Server 2008 R2 to Windows Server 2016. New operating systems require more processor power, more memory, and it has higher storage footprint. So we needed new resources. What we did? We started the conversations with the hardware vendors. And what we saw the new trend on the market for particular solutions going back from virtual to physical. An example would be HP Moonshot. At that time, it was classical approach. So we had a bunch of Blade servers running Hyper-V on top of it and virtual machines with terminal servers. Yes, it is classical approach. At that point, we decided to change the architecture, go for bare metal, and we ended up with this solution. So we replaced 444 virtual machines running old operating system with physical servers it is running Quanta Yosemite servers. So here we have 168 monolake servers. So it's Yosemite version 1 with the newer operating system. How we get to this point? We wanted to achieve 4 points. Give our users better user experience. Nowadays, we don't want to wait. We want to have everything very fast. We had to meet the requirements of the newer operating system. We wanted to improve the TCO, and finally, we wanted to keep the environment as simple as it can only be. The year 2016, as Jarek said, Quanta provided us samples of Yosemite servers. So we took them and said, why don't we test them as terminal server? It's something that usually people don't do. They put Linux on this and use this for other purposes. So we tried this as terminal servers, and we decided to run some performance test. So at that time, we had Blade servers, 2-socket CPU, plenty of RAM, and mid-range storage array. Classical approach. On the other hand, we took one monolake node, so one computing unit, with only 1-socket CPU, with not so many RAM, and with the fast SSD drive. Someone may ask, how did you compare those two completely different scenarios? Here, Blade servers, Hyper-V virtual machines, and here the physical server. Here comes the Login VSI. What is Login VSI? It's the benchmarking tool for the, in general, terminal solutions. How does it work? Login VSI consists of the launcher. What launchers does? It connects remotely to the terminal server and simulates the work of the user. So it starts Word, Excel, scrolls some PDF files just to generate the load. And it creates many connections to the terminal servers. It comes up with the Login VSI Max. What does it tell to us? It tells it's the maximum capacity of your virtualized desktop environment. So it tells us how many users can work on this solution or on this solution with very good user experience. We came up with these numbers. On the Yosemite, we can have 52 users with the very good user experience, with the very high load. On the current Blade servers, we could have 82 users. One may say, okay, you still get more users on the Blade server than on the monolake node. Here we have more, and here around 50 users. That's all true. But keep in mind that this, on the Blade server, we can achieve with 11 virtual machines. And the other thing is that Blade server, it's composed of 2-socket CPU, plenty of memory RAM, you have the storage array behind this, you have the fabric channel network behind this, and here we have just single monolake node, which has the density of 62% from 11 VMs. And now the savings. So basically, at the end of the day, we have the TCO reduced of 35% and operational costs of 30%. One may ask, how did you achieve this? So let's go back to the year 2016. We sent some requests for prices for the classical architecture, so virtualization, let's say Hyper-V, virtual machines. We calculated how much classical approach servers we need, and we did the same with the OCP. We compared the prices. Here we have the Blade server, the mid-range storage array, the fabric channel, switches, and so on and so on. And here we have the OCP. The difference was significant. So this was the main difference here. Next, before we had the plenty more than 54 Blade servers, which comes with the management costs. Yes, you have to patch them, you have to upgrade everything on them. You have the storage array, you have to take care of the fabric channel, and at the end of the day, it creates many operational savings. Next, before the decision was made, as Giuliano from Facebook said, this solution, I'm talking about Yosemite OCP, has some minuses. Also, the pluses. So we thought deeply about all pluses and minuses before making the decision. Let's start with what we really liked in Yosemite. It gave us very good performance. We did savings on Microsoft licensing. Why we did this? Because in the classical approach, you have to provide data center licenses for your virtual machines. Once you go to the physical, you can stay with the standard licenses, which are much, much less expensive. We get the very fast SSD drives. The cons would be that we still have to, if you go for Yosemite, you have to upgrade the BIOS on the firmware on the high number of devices. You need more port on the physical switches. And this is, for us, it was very important that the diagnostic is more difficult. Why? Yosemite server doesn't provide you the GUI, let's say, GUI controller direction. So, in fact, before the system comes up, you don't fully know what's happened on them. You can redirect the COM port, etc., but for the diagnostic, it was not so easy. And then we saw that in case of failure of one Yosemite, we have impact on 50 users. Okay, now move to the classical approach. In the failure of one virtual machine, we have impact on only 15 users. That's good news. But on the other hand, if something bad happens to the Blade server, we have impact on 168 users. Then the classical approach, it's more universal. You can use this for another purposes. It gives us more flexibility. You can add more virtual machines if they are needed. And what are the minus? The classical approach, it always comes with the overhead of virtualization on CPU. And this is significant. That's the end of our presentation. Thank you very much for listening. It was a pleasure for us. If you have any question, that's a good time for this.
Thank you.
Okay.